Okay, for these two logarithm rules, we need to remember three things that are always true with logs. First of all, if I take a log, any base, and say a times b, well, that's the same as log a plus log b. So I can separate they're multiplied inside the log, they're added outside the log. Similarly, if I have log of a over b, that's the same as log a minus log b. And then a third rule is that if I have log of something to a power, like a to the r, that's the same as r times log of a. These little rules are pretty nice because they can help turn products into sums, division into subtraction, and exponents into multiplication. And we do use this fact, exploit this fact sometimes in calculus, when things are easy to do when they're adding, subtracting, or multiplying. Okay, so over here, we're meant to combine this into one log. So let's see, what can we do to bring this 3 in? We're going to use this rule right here and say this is natural log of 2x cubed. That's the same using that rule right there. Minus, how can I bring that 9 in? Well, that would be natural log of y to the 9th. Now that y has been brought in. Plus, well, let's see, this is natural log of z squared, but then I'm going to raise it to the 4th power. Natural log of z squared raised to the 4th power. Okay, well now I have a subtraction, which I know is the same as division inside the natural log, and an addition, which is the same as multiplication inside the natural log. So this would be natural log of something. Some things on the numerator and some things on the denominator. Well, this is definitely on the numerator. 2 cubed is 8, so it's 8x cubed. This is also multiplied over here, and this is divided, so I'll put that y to the 9th on the denominator. This adding is the same as multiplying, so I'll put this, which is really z to the 8th, on the numerator. Now everything is in terms of one logarithm, specifically the natural log. Here they say, let's simplify the answer. Well, here this is log base 2. So just as a reminder of another rule with logarithms, if I say log base b of x equals y, I can rewrite that to b to the y equals x. That logarithm formula and that exponential formula say the same thing. Those two equations say the exact same thing. So I can figure out what log base 2 of 16 is and log base 2 of 4 is. But I don't have to do that right away. I could, but I could also combine these if I wanted to. Log base 2 of 16 plus log base 2 of 4 using this rule is the same as log base 2 of 16 times 4, which is log base 2 of 64. Okay, so now I've turned it into one logarithm, but now it says I should simplify it. Well, I can rewrite this expression right here, knowing that if this is the same as, oh, say y right here, the y right here, then I can rewrite that to say, well, 2 to the y equals 64. And I recognize 64 is a power of 2, so this will give me like an integer answer. You might know that 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, and 2 to the 6th is 64. So in this case, y is just the 6. And there you go.